In this video, we'll be discussing derivatives, some basics, including radicals. Yes, so for this concept, what we'll be focusing on is to simplify the radical such that our term, which is this term, it can look like this, which is x to the power n, so that it can look like this, where n can be a fraction. Yes, n can be a fraction, like ax, my a is like a 9, apologies, ax to the n to the negative power, which is ax to the 1 over n. So the aim is to get it to this form, basically. Yes, this is the main aim of the day. So let's take this one to start with. So we have the nth root of x to the b. So to start with, it will be x to the b first, and then to the 1 over nth power. You know, this b is over 1, so we have x to the b over 1 times 1 over n, which is x to the b over n. Yes, apologies, my writing is bad. Let me just do this. Let me reduce the thickness. Yes, black is fine. So yeah, yes guys, so once we have it in this form, you see here we have our a, here, which is 1, and then here it's x, and then here it's our exponent. And then once it's like this, we can start to differentiate. But while it's like this, in the form of a radical, we cannot differentiate here. We cannot differentiate here. So the aim is to get it to this form, and then once it's in this form, we are done. So to kickstart, we can test this example over here. Let's say the question is find f prime of x. So we have f of x as 2 root x. Now when it's like this, we can't continue. We can, but let us make our life easier. So we have to simplify f of x first. So it will be 2, and then we know the square root, it's x to the power half, and then now it's of that form of a x to the power n, where power n is a fraction in this case. And then we can start to apply the normal power rule. Then we drop the exponent, so it will be 2 multiplied by half x, and then from that exponent we subtract 1. Yes, and then we differentiate the inside. The derivative of x, it's nothing but 1. So here we have 2 and 2, they're gone, so we have x. Then 1 minus half, it's negative half. Then to write it in positive exponent form, it will be 1 over root x. Then this will be our f prime x. I think I couldn't write it properly. I will write properly for the next example. Apologies for that. Yes. Now let us test this one. So this was example 1. And let us test example 2, whereby now we have g of x is equals to 2 over root x. Yes. Now, even when it's like this, what we must do is to get rid of our radical from the denominator and take it to the numerator. But first, before we do that, we must write it in this form first. And then this is still our g, remember? And then we can now move it to the numerator. So we'll have 2x to the power The exponent is positive. When it goes up, it will be negative. So we'll have this. This is still our g. Yes, now let me have order now. And then let me say g prime of x then. G prime of x, it will be 2 times, we drop the exponent, x, the exponent, negative 1/2 minus 1. And then times the derivative of the inside, which is 1. This. Simplify, we have minus x to the minus 3/2. And then simplifying so that x can have a positive exponent with negative 1 all over x to the positive power. And then if we can write this in radical form, we'll have minus 1 over the square root of x cubed. Yes, guys. I'm sorry I'm running out of space. My board is still small, but yeah. Let's have maths for fun. And let's try that one. This one I'll make it interesting. This one will have h of x as 2 that root of x squared minus the root of x. Yes. Now, first we must simplify h fully. Then we'll have 2 x squared to the 1/3 power minus x to the 1/2 power. Then we simplify fully. So we'll have x to the 2/3 minus x half. Then now we can do this is still our h. Remember, let me undo this. This is still our h. Now, yeah, let me write it this side. Let me decrease the thickness. Yes. So h prime of x will be 2, and then we drop that power, 2 over 3x, 2 over 3 minus 1 there, minus, drop this power here, and here we dropped it, and then minus 1. Yes. Now we drop that half, x to the half, from that half we subtract 1, then we'll have, this is over 1, so we'll have 4 over 3x to the negative 1/3 minus 1/2 x to the negative halves. Is this correct? Let me check. Minus 2 over 3, yes, this is minus 1/3, yes. So this will be our h prime of x, guys. And let me add another page here, another example, I mean the fourth one. Let me read the question, the h. So for another example, we can have k of x as the square root of x. Now this one I want to put a star, because this is our famous friend. The derivative of the square root itself, so you will have our k prime of x as 1 all over 2 times the square root of x. Yes, this is the answer. The derivative of x, it's 1 all over twice the square root of x. Yes, so even the integral of this must be that plus cs. Yes, we'll cover integration later as time goes on. Number 5, let's see what we can have here. The last one, z of x is equals to 7 the 7th root of x to the power 7. Yes. So here we must simplify z first. So we'll have 7. The x is to the power 7, but the exponent 1 over 7th power. So we'll have 7 x to the 7 over 7, which is 7x. This is still our z of x. And then you can guess z of x will be 7. Yes. Let us just include a special table. Let me see, this is a special bonus for the video. So if we have, let's say this is our function, and then this is our derivative. Yes, derivative is like the slope. Now if we have the square root, we know already it's 1 over twice the square root of x. Let me just try and create a linear table here. Come on, man. Yes, this is my table function, the special bonus for the video. Yes, if our function is square root of x, so my handwriting is bad, guys. I'm still adjusting to the drawing board. Yes, but yes, the function is the square root of x, and the derivative is 1 over twice the square root of x. So if we have the derivative of x, it will be 1. But let me just make it interesting now here. If we have the derivative of ax, note that a is not equals to 0. It will be a. It will be a, guys. So yes, that's part of the bonus. That's part of what I had today for you guys. And I think let's add one more. Let's add one more. That's how I'm gonna get used to the board, by adding more examples so that I can get used. So without any waste of time, what we can add here is 4. We all know by now the derivative of any constant 4 is 0. So even the derivative of 0 should be 0.